I'm here to dissect the topic, turning agricultural waste into eco-friendly products. So, first of all, what are plastics? Because we hear plastic every day, we make use of plastic materials every day. So, plastics are materials that are manufactured through the use of petroleum, or let us say fossil products. You know how we get our petroleum? We get our petroleum from the underground. We dig into a certain depth to get petrol. So today I'll be talking about how those agricultural waste can be turned into bioplastics and that are eco-friendly. So my first slide, the plastic problem in Africa. So in Africa, we are more dependent on plastics, or let me say fossil-based plastic. Fossil-based plastic they are also the same as petroleum-based plastic, because every day we use single-use plastic. For example, now let's assume some of us went for an event. We went for an event. We are served plastic spoon. So that plastic spoon, we are not going to use it after using it to consume the food that we are given. We will dispose it. So that is one of the problems in Africa. We use single-use plastics. So, and that is one of the problems causing Persistent pollution is basically the presence of plastic waste in the environment where they are not needed. So my next slide is going to give a glimpse of what I'm trying to explain. So here now, this is an ideal example of a plastic waste. I can see, as you can see, this is a plastic waste in a landfill. So, and as you can see now, that this one is not eco-friendly, because a plastic basically have a longer duration of degrading. If you understand what I'm trying to say, they take 20 to 100 years for an ideal plastic, just an ideal plastic, not plastic bottle. They take 20 to 100 years before disintegrating, and when they disintegrate, they don't. They are not of biological importance. They are not eco-friendly. They harm the soil rather than adding back to the soil. So my next slide, how we got here. Plastic has revolutionized the modern society through the use of plastic that are durable and of low cost. So due to the fact that plastic are of low cost, that is why we are able to purchase them, and that is also one of the reasons why we have plastic pollution in the society. And it's quite obvious that why we are when we go out there, we go into the towns, not in the school, not in the school premises, let's outside the school, we see a lot of plastic waste out there, and we are citing a problem, we are citing a solution in order to replace them with bioplastic. So my next slide, this is also an example of plastic pollution, or let's say plastic waste pollution that we are currently dealing with in Africa, not just in Nigeria. It's an African problem, or let me say it's a global problem, but it is very imminent in Africa, most especially. So my next slide. A scientific shift in material design. So science is stepping in to find a solution to fossil-based plastics, replacing them with bioplastics. So bioplastic is now the solution, or is now the scientific-driven alternative to replace the traditional or convenience plastic that we're using in our daily life. So the scientists make research on a particular agricultural waste that is very rich in making a perfect bioplastics. My next slide. So this is where everything starts from. This is a glimpse of the scientists making research, because it all starts here before moving to the industry, before moving to the society. it always starts in the lab. Whenever we are dealing with something scientific, we go to the lab, we test it, we experiment on it, or if there is a need for further experiment, we go further, and from there arriving at what we need at that time. So next slide. The agricultural waste in Africa. So agricultural waste in Africa are agricultural waste that are selected or driven, like should I say, taken out, separated, that are very fit for making bioplastics. So over the course of the research, there are many records or many researching claiming that some agricultural wastes are useful in making bioplastics. So my next slide. So these are, in case you don't know what an agricultural waste. So of all the waste here, there are many of them that are very useful in making bioplastics. It's a matter of making research, a research that is well done, a well done research. Because when there is no evidential research, we won't arrive at this result. Next one. So avocado is a case study now. Is a very good and well verified material in the use of bioplastic, because they contain ligocellulosic materials or ligocellulosic materials like cellulose, starch, that are very, very good for making bioplastics. So next slide. So, and over the research, because as a scientist, as we are science oriented, there are some chemical substances that will be very essential in the making of those things. So, and at my picture here, we have the amylose and the amylopectin. The amylose is a straight chain polymer of the D-glucose. So the amylose is one of the integral organic substance, let me just say organic substance, that they are very good in the use of making bioplastic. And the second one is the amylopectin. The amylopectin is a branched chain polymer of the D-glucose unit. They are more like twins, and they go in hand. So they are very essential in the making of bioplastics. So if they are not present in those wastes, I don't think you get the results we are looking for. Next slide. So this is a glimpse of the PSC. So this is an ideal bioplastic raw material that we can use to make bioplastics, like the plastic cup we use, the plastic cup we use, the plastic plates, and some other plastic products we use in our everyday life. Next slide. So from waste to spoon, there's always processes used in making those bioplastics. We can't just select them, put them together, and just put them into production. There's always steps like cleaning, sorting out, and from there extracting those important substances that are needed for making the bioplastic. So from waste to spoon just is a summary of how they are being made. It's a summary of how the processes, the essential processes used in making those bioplastics. Next slide. So these are the bioplastics. They are quite, or let us say, a little bit different from the normal plastic, the fossil or petroleum-based plastic we use in our daily life. This is a picture of those plastics we use that are made from biomaterials. They're called biomaterials. Next slide. So other ways that bioplastic can be manufactured. So we have different ways in which we can manufacture, or we can manufacture bioplastic. So there's a directive extraction of natural polymers. We have the starch-based the starch-based plastic, we have the cellulose-based plastic, and we have the protein-based plastic. So in the case of avocado seeds, it falls under cellulose-based plastic because cellulose and starch, they are present in the avocado seed. But in the case of cellulose-based plastic, cellulose has a higher percentage. Not that there is no starch, but cellulose dominates in terms of the material. So the using of avocado seeds falls under the cellulose base. So the using of avocado seeds, it falls under the cellulose based plastic. That's right. So this is a picture of other ways of bio-based plastic are made from a wide range of renewable bio-based feeds. So these are other ways to get biomaterials, not just from agricultural waste. We can get them from trees. We can get them from even the food we consume. But not all the food we consume. There are some raw materials or raw food that can be used to make bioplastic. So these are the ways we can get them. We have the agro-based feedstock, we have the lignin cellulosic feedstock, and we have the organic waste feedstock. That's right. So the economic and cost consideration. The economic and cost consideration lies in the way we can like, if we want to replace bioplastics, if we want to replace them, if we want to exclude the petroleum based plastic with the use and replacing them with bioplastic, we must consider the economic and cost. So the first one is the net present value analysis. We must consider that. The second one, the revenue risk of policy, because in Africa we are very, very, very dependent on petroleum-based plastic, which is very bad, and there are consequences attached to that. We see every day in a particular state, there are plastic polluting, blocking drainage doors, blocking the gutters, blocking, even polluting the environment. So the second one, the last one, the strategic industrial shift. So the strategic industrial shift, like Ghana and Kenya, they are repositioning their industrial strategy in terms of producing the shifting from the traditional way of making plastic to making use of bioplastics. So the next slide. So this is the analysis. This is the analysis as of 2018. I'm sorry, this is an old analysis, and as we all know, this the manufacturing of bioplastic is not mainstream yet. It's still a work in progress, particularly in Africa. But in some other countries worldwide, globally, there's something that they make use of every day. But in Africa, it is not yet mainstream. It's a work in progress. So next slide. So benefit to Africa, a benefit of bioplastics to Africa. There are varieties of benefits that when we make bioplastic our ideal way of making plastic, there are of benefits to Africa. The first one is cost effective for small businesses. The second one is hygiene in formal market. So hygiene is very important, because when you use a plastic, let's assume someone make use of a plastic spoon, and you after consuming the food, you either throw it somewhere else where it won't be appropriate to dump it there. And that's why you always see some bottles there's always an inscription, recycle me or dispose appropriately. So that is one of the benefits of bioplastic to Africa. The last one, job creation in the manufacturing industry. So when we shift to making bioplastics, there will be job creation in the manufacturing industries. Next slide. So this is also a picture of a bioplastic product. Next slide. So consequences of inaction. The consequences of inaction. If we fail to embrace bioplastics, if we fail to embrace, the manufacturing or the use of agricultural waste to make plastics, there are some issues that will always be coming up. So the number one is persistent pollution. Persistent pollution, like the previous pictures I showed the other time. I think there's no need to show this. They can be between 1200 and 1000 years to decompose in landfills. That is why I said the duration at which plastic, the traditional made plastic, disintegrates takes longer. And I said it is between 20 to 100 years. It takes a very, very long time to disintegrate. And I said it is not because of it is of no ecological importance. It does not add back to the soil. It further harms it. So the second one is marine and wildlife trade. So when there is persistent pollution of plastic waste released into the water bodies, we are threatening aquatic life. There will be scarcity of some particular aquatic life in the water. So the last one, resources depletion. So if there is persistent use of our traditional way of making plastic, the resources used in making them will definitely decrease. So there will be decline in the resources used in making the petroleum or fossil-based plastic. So this is another picture showing the consequences of persistence, the consequences of using petroleum-based plastic. So you can see that it's causing a lot of problem. Next slide. So conclusion and future outlook. So transforming agricultural waste into eco-friendly products should be embraced because there are a lot of benefits. Because in the case of bioplastics, the reason why scientists optioned out bioplastic as the ideal way of making plastic is that it is eco-friendly. So and the bioplastic, the duration of the bioplastic, the duration of disintegration is between 7 to 14 days. You can see that it is very, very shorter. And while disintegrating, there are a lot of advantage. There are a lot of nutrients adding back to the soil because they are gotten from biomaterials. So thank you for listening.